Okay, chapter 2 deals with absolute value. We're going to be working with the absolute value function. So absolute value, the bars denote that we are dealing with absolute value. So absolute value is the distance between x and 0 on a number line. So if we have a number line, we have -5, 0, and 5. The absolute value of -5 is positive 5 because we are 5 units away from 0. Same thing when you have the absolute value of positive 5, your answer is just 5 because you are 5 units away from 0. So section 1 deals with graphing the absolute value. So each graph has a parent function, and that's their home function. It's what you pretty much dealt with in chapter 1 on some of those worksheets. You were given the parent function and you had to move it. So we have our parent function is always going to start at the origin. It's going to start at 0, 0. We then go out 4 units and up 4 units, and those are going to be some points that are on this graph. But the main thing to note is that the parent function always starts at 0, 0. And that's your vertex. Your vertex is where your graph, where your two lines meet, where your graph starts. That's your vertex. And it's represented in that formula that we dealt with in chapter 1, that big long one that you have your note card for. It's represented by h and k. So in this case, h would be 0 and so would k because it's the parent function. So if we look at example 1, we want to graph the absolute value functions, and here's our formula. So we know we're dealing with absolute value because of this bar. So we know we're going to have a V-shaped graph. Absolute value always has a V-shaped graph. A is still changing your y value by a factor. B is going to change your x value by a factor. H is going to slide on the x-axis, and k is going to be sliding on the y-axis. So our example is g of x equals 4 times the absolute value of x minus 5 minus 2. So our function, or f, that appears when I wrote your formula on your note card is the absolute value function. That's just telling you you're dealing with functions. So in this case, I want to label what I know. I know that a equals 4. I know that h equals 5. And I know that k equals -2. And that's just pulling this straight from this formula, A, H, K. Okay? Since h and k denote my vertex of the graph, this point 0, 0 of my parent function, because that's what I have drawn here, point 0, 0 is going to move 5 units on the right and 2 units down. 5, -2. So that is going to be my starting point for this graph. Now, if you look on this parent function, we have points 1, 1 and 1, -1. And those are always going to be the points you want to deal with. You only have to deal with 2 or 3 points with these graphs, and you can kind of see what direction it's going to go. So always focus on 1, 1 and 1, -1. Or -1, 1, sorry. So 1, 1 and -1, 1. So in order to see where that point 1, 1 is going to end up, I know h is moving me in my x direction. So in order to get my new x value, I'm going to take 1 plus 5. So I'm adding 5, I'm moving 5 units. My y value, not only is it being shifted down 2, we also have this a factor. So it's being multiplied by a factor of 4. So I'm going to take 1 times 4, and then I'm going to subtract 2. Technically taking the absolute value of 1 and multiplying it by 4. So this point, 1, 1, is going to become 6, 2. Absolute value of 1 is 1 times 4 is 4. 4 minus 2 is 2. So my new point over 1, and I'm going to go up to 2. So this point is 6, 2. Okay? So now I also need to find what negative 1, 1 is going to be. So I'm going to do the same thing. I'm moving 5 over on the x-axis. So I'm just going to do that over here in red. So negative 1, 1 is going to become, if we had point negative 1, 1, it's going to become negative 1 plus 5. And then again, to my y value, I'm going to say the absolute value of 1 times 4, because a is 4, and I'm going to subtract 2. So this is going to become 4, comma, 2. So negative 1, 1 is going to become 4, 2. So 1, 2, 3, 4, and up to 2. So then your new graph for this equation is going to look like this. It was stretched vertically, so it became skinnier, and it has moved locations, and this point is 4, 2. So this was your parent function. This is your function g of x, that g of x function. So let's do another one. This time I have g of x equals the absolute value of negative 1 over 2 times the quantity of x plus 3 plus 1. So again, label what you have. I know that b equals negative 2. I know that h is negative 3, because remember, if it's positive, that means it's a negative number, and that k equals 1. So that's what I know off of this formula. So here's going to be my parent function. I'm going to have my vertex at 0, 0, and then I'm going to have points at 1, 1, and 2, 2, and stuff like that. So that's my parent function. It's going to go out like this. Sometimes it helps to draw the parent function so you guys can see it visually and mathematically. So then, my new vertex, remember h and k denotes my vertex. H is the x, k is the y. Negative 3, 1 is going to be my new vertex. So 1, 2, 3, and up 1. Negative 3, 1 becomes my new vertex. So again, I'm going to look at those points 1, 1, and negative 1, 1. So if I'm dealing with 1, 1, this time, remember, b deals with your x value, a deals with the y value, b deals with the x value. So this time, since b is negative, we're going to have a reflection. And we can go ahead and deal. We know that the y unit is going to move up 1. Just because k is 1. So 1 plus 1. Okay. B affects my x unit. So I'm going to say that 1 times negative 2 minus 3. So I kind of ran out of room. But 1 times negative 2 is going to be negative 2. Negative 2 minus 3 is going to be negative 5. And that point will be 2. So 1, 1 is going to become negative 5, 2. So this is negative 3, negative 4, negative 5. I'm going to go up to 2. Again, you can pick negative 1, 1. You can pick 2, 2. You can pick negative 2, 2. You can pick any point from that parent function. So dealing with negative 1, 1, my x value, b is negative 2. I'm going to say negative 1 times negative 2 minus 3, comma, 1 plus 1. So negative 1 times negative 2 is 2. 2 minus 3 is negative 1. And then that point is going to be 2. So negative 1, 2 is going to be your other point on your graph. So your new function will look something like this. It's going to be spread out more because we are dealing with b. And then, meaning we're going to have the horizontal stretch instead of the vertical stretch. And then we moved our vertex over. And that is how you graph the function. So the reason why I showed you the tables in chapter 1 was because it showed you what each thing did to your x, what each parameter did to your x and your y value. So that's something to remember, to recall from chapter 1. Don't ever forget what we learned in the past. It'll always come back. So just because we took a test on chapter 1 does not mean that we are done with stuff from chapter 1. Example 2, we want to write the equation given the graph. Okay. So we are told, we are given in this problem that a equals 1. And looking at the graph, my vertex is this middle point here. So looking at the graph, I can tell you that h equals 2 and k equals 5. So far, we know that a equals 1. So we're going to say g of x. We know a equals 1, so we don't have to write it. We're going to have the absolute value of 1 over b, because we don't know what b is, times x, that's always going to be there. H is 2, so that means we're going to be minus 2, and we'll have the absolute value ending, and we're going to add 5 to it. So that's what we have so far. So we have an unknown. We don't know b. They give us this other point of 6, 6. We're going to plug that in. So we can say 6 equals the absolute value of 1 over b times 6, because x is 6. We're just going to pull that in. This is y. 6 equals the absolute value of 1 over b, 6 minus 2 plus 5. Deal with your parentheses inside the absolute value first. 6 minus 2 is 4. So we'll have the absolute value of 1 over b times 4 plus 5. That's going to equal 6. And then we're going to subtract 5 from both sides. So we'll have 1 equals the absolute value of 1 over b times 4. And then we're going to divide. Well, since we have the absolute value, we've set up 2 equations. So 1 equals 1 over, we'll say 4 over b, because that's what technically that is. Or we have 1 equals negative 4 over b, because remember with absolute value, it can be a positive or it can be a negative. So in order to get b by itself, we're going to have to technically divide by 4. we're going to do it this way. We're going to multiply both sides by b, actually. Multiply both sides by b. So b is going to equal 4. And if we multiply both sides by b, b times 1 is b, b can equal -4. So then based on our problem, we're only going to consider b equals 4. So if b equals 4, our formula, our equation is g of x equals 1 over 4 times x minus 2 plus 5. Okay? So let's try another one of those. This time b is going to equal 1. So I know b equals 1. Looking at this, my vertex is at 1, 6. So that means h is going to equal 1, k is going to equal 6. Starting off with what I have, g of x is going to equal a times 1 over 1, because b is 1. And then x minus 1. Close your absolute value, and we're going to add 6. So this time, we don't know what a is, meaning we have to solve for a. And they gave us the lovely point of 0, 3. So 3 is my y. 3 equals a times the absolute value. X is 0. We don't need to write our b because it's 1. Plus 6. So we're going to subtract 6 from each side. -3 equals a absolute value of -1. And then we can say, since the absolute value of -1 is just 1, it's a times 1 equals -3, a is going to equal -3. So since we now know a, our function becomes g of x equals -3 times x minus 1 plus 6. Our last example is a word problem. Example 3 is on modeling. At a science museum exhibit, a beam of light originates at a point 10 feet off the floor. It is reflected off a mirror on the floor that is 15 feet from the wall the light originates from. How high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? So let's go ahead and draw this out. My light, here's going to be my light, is 10 feet from the floor. Okay, the mirror is 15 feet from the wall that the light is on. And then the other wall, so my other wall, is 8.5 feet from the mirror. So my light is going to come down and hit this spot, and then it's going to go up and bounce off of this wall. So we want to know how high this spot is. So first things first, I'm going to look at this and say, well, the walls are 23.5 feet apart. Okay, so that's going to be my x value. The vertex of this graph is going to be at 15, 0. So vertex since we're 15 feet before we bounce back off, is at 15, 0. And then another point that our graph has given us is 0, 10, because we are 10 feet off the ground. So starting off with our graph, we have g of x equals a times the absolute value of x minus 15 plus 0, because that's our vertex, h and k. h, k. So now we can use this point 0, 10 to find what a is. And in this situation, we want to let b equal 1 because we're not reflecting or stretching or anything in that matter horizontally. So we're going to substitute 10 equals a times the absolute value of 0 minus 15 plus 0. So 10 is going to equal a times the absolute value of negative 15. And then 10 is going to equal a times 15. And then we're going to divide both sides by 15. And we get a to be 2/3. So then our formula that we are going to use, so we use that point to find everything missing from our formula. We're now going to say that my formula for this graph is g of x equals 2/3 x minus 15 plus 0, which you don't even need to write the plus 0. And then what our original question was, is how high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? So that's why that distance of 23.5 feet comes into play, because I want to know how high, that's my x value, how high this is. So we'll just call this y instead of x. We want to know how high that is. So I'm going to say g of 23.5 is going to equal 2/3 times since it's g of x, it'll be 23.5 minus 15. And when you do that in your calculator, you get 17/3, which is about 5.67 feet. Your homework for this section is page 54, 55, 2 through 18 even. If you have any questions, you guys know to message me.